Now, before we step into this function of a function, let me ask you one question. Have you ever looked at any mathematics question before, especially when you are writing an exam? Immediately the question paper was distributed to you from the invigilator, you started having different thoughts. You started asking yourself, this is not true, this is not so. None of the topic or none of the question which we prepared for came out, and this is too hard for me. Yes, it happens. But what if I tell you today that the difference between students who excel in mathematics and those who struggle in mathematics is not solely measured by intelligence, but by confidence and practice? So in this video today, I'm going to explain the concept of calculus, which is called composite function or function of a function. Before we can have a proper understanding under this function of a function, let me explain what function is in mathematics. Now, by definition, function is a rule or principle that defines the relationship between two variables, where one variable is dependent and the other variable is independent. Now, take note of this, because we said a function must be an equation, and in that equation there must be two letters present. So a function comprises of two letters only. So what should be the example? A, B, and C? No. X and Y. Alright, that is correct. In a set of equation, y is equal to 2x squared plus 3x plus 4. This is an example of a function in mathematics. Another example is y is equal to 4t squared plus 3t. Another example of a function is w is equal to 6p cubed plus 3p plus 5. All these are examples of function in mathematics. Again, before we can have a proper understanding of what function of a function is, one must note the meaning of derivation in calculus. Now, by definition, derivation is the rate of change of one quantity with respect to another quantity. Example, if you are considering the first function on the board or the first equation on the board, where y variable is equivalent to x variable, and we are required to determine the derivation of this, because we said derivation is the rate of change of the dependent quantity y with respect to the independent quantity x. Then it will become the rate of change of the dependent quantity changing y with respect to the rate of change of the independent quantity change in x. This symbol is for delta, and which represent change. Because we are talking about derivation, we can represent this change by d. So it becomes dy all over dx. And this could be read as the rate of change of y with respect to x. Also, if we are considering the second example on the board, which is the second function, where we had only y and t, the derivation of this function is not going to be dy over dx. Take note of this. In this function or in this equation, we have just y and t, two letters. So the derivation of this function becomes dy all over dt. Therefore, from the second equation, the derivation becomes dy all over dt. Also, if you are considering the third function on the board or equation on the board, the derivation of this function, because there are two letters w and p, that will become what? So it will become dw all over dp, which is read as the derivation of w with respect to p. Now, let me give you a little task. If, for example, I'm giving you the arrow divided by the dk. What will be the expected mathematical equation or function for it? If you know the answer, put it in the comment section. Also, let us consider the general rule for derivation. Now, for example, if you are considering the first equation on the board, where y is equal to 2x squared plus 3x plus 4, and you are required to determine the derivation of this. Is there a general formula for it? Yes, that is the good news. There is. So, for instance, if ax raised to the power of n is given to you, where a and n are whole numbers and x is variable, the derivation becomes this power times the coefficient, that is a n, then x raised to the power of n minus 1. In this case, we are only required to use the power to multiply with the coefficient of the variable, then subtract 1 from the power. Example, let us solve the first function on the board. Y is equal to 2x squared plus 3x plus 4. So y, that is number 1. Y is equal to 2x squared plus 3x plus 4. So in this case, we are going to apply the derivation formula to each of the respective terms on the board. You apply the formula to this term, and also to the last term on the board. That will give dy over dx will equal to multiply the power by the coefficient. 2 times this, that is 2 times 2, then x raised to the power of 2, subtract 1 from the power, minus 1, plus the same here. The power here is 1, so 1 times 3. That is 3 times 1, x raised to the power of, there's an invisible 1 as a power in this x, 1 minus 1, then plus 4. Now take note of this, the derivation of a constant term is always equal to 0. So that will be plus 0. So over here we have dy over dx. Dy over dx will equal to 2 times 2 is 4, x raised to the power of 1. 2 minus 1 is 1, plus, over here, 3 times 1 is 3, then x raised to the power of 1 minus 1 gives 0, and x raised to the power of 0 is going to give you 1. According to the law of indices, any quantity raised to the power of 0, the result is always 1. So if you multiply 1 by 3, you obtain 3. And this is the final result. Let us consider the second function on the board, where y is equal to 4t squared plus 3t. 4t squared plus 3t. Okay, so the derivation of this function on the board is not going to be dy over dx. What is the reason? The reason is because the letters in this equation or in this function is y and t. So the derivation of the function becomes dy over dt. So we have dy over dt would equal, applying the formula, the derivation formula, we have 4 times 2, then t raised to the power of 2 minus 1, plus, applying the formula over here, we have 1 times 3, or 3 times 1, t raised to the power of 1 minus 1. Take note that the power at this t is 1. So if you multiply this by this, you obtain 1 times 3. So that will give dy over dt will equal to 4 times 2 is 8. Then t raised to the power of 2 minus 1 is 1. That is 8t plus 1 times 3 is 3. And t raised to the power of 1 minus 1 gives 0. Note that every quantity or any quantity raised to the power of 0, the result is always 1. Then when you multiply 1 by 3, you are going to obtain 3, which is the final result. Let's look at the example number 3 on the board. So the function on the board is W is equal to 6p p raised to the power of 3 plus 3p plus 5 plus 3p plus 5. All right, at this juncture, the letters present in this equation or this function is W and P. That means the derivation becomes what? The what? The W over the P. So the W over the P would give, I'm going to omit some of the steps in this point. So we are going straight to the point. 3 times this is 18. So we have 18. Then subtract 1 from the power. That is 3 minus 1 is 2. So p raised to the power of 2 plus, over here, what is the power of the variable p? Is 1. That gives 1 times 3, which is 3. Then if you subtract 1 from this 1, we have 0. Because the rule states that we have to subtract 1 from it. And we have 1 minus 1, that is 0. And any quantity raised to the power of 0 gives 1. All right, so we have 3 plus, the derivation of a constant term is always 0. So the final solution becomes 18p squared plus 3. The W over the P is equal to 18p squared plus 3.